The next speaker will be Michael Walker to talk about the
Let's go on. My name is Michael Walker. I'm the reporter for Group 2. We did the engine performance experiment on Tuesday. So just a quick overview. This is how we're going to talk about it. First, we're going to talk about the objectives of the experiment, an overview of how the experiment performed, and then we're going to go over data, results, and some calculations. Some basic objectives of this experiment included to show the variation of basic engine parameters under the different engine loading conditions, and we did this through 2 tests. We had the constant load variable speed test and the constant speed variable load test. In the variable speed test, we talked about basically we set the engine at a load and we would increase it from 0 or from idle to max RPMs for a period of 5 seconds at a time. And for the constant speed variable load test, we set the RPM at approximately 2,500 RPMs and then increase load in variations of 10 every 5 seconds. So that's pretty much what I just said. So. All right, so this was the experimental apparatus that we used. To the left is the engine that was used. It's basically a knockoff Honda engine that you can get at Harbor Freight. And this was the main controller. This is where you could manually control the RPMs of the engine. And this was the readout screen. Basically collected all the data for the screen. And as you can see, there's a lot of different gauges, but for the most part, we're just concerned with this graph right here. Because this apparatus can do a lot more than what we were actually using to take the test for. So for the constant load variable speed, we did 4 runs. This is the 0% load. I had to delete some data points for this to try to get it into a more linear line. There was some large flat lines on it. 10% load, you can see the difference there. You can see a small increase in both horsepower and torque. Again, at 20% load, again at 30% load. So, how load and torque, how load affects torque and horsepower. Engines actually like to run loaded. They run better loaded than non-loaded, actually. But basically, torque is a measure of how much rotational force an engine can produce, and horsepower is how fast the engine is capable of delivering that torque to the load. And as you can see from this highlighted equation here, just from some basic equations, you get your horsepower is equal to your torque times your revolution per minute divided by 5252, which means eventually at revolutions above 5252, your horsepower will actually overcome your torque, which, as you can see from the R trend lines, they both climb together, but horsepower does kind of climb a little faster. So for the constant speed variable load results, this was control speed run 1. We did 4 of these. So we set the RPM counter at, I think it was, for us, it was right around 2550. That's about as close as we could get it. And it kind of oscillated from there. But this was at no load, as you can see. It's very jumpy. And then here, every 10 seconds after that, or every 5 seconds after that, we increase the load count. So it went from 0 10 to 20 to 30 and then 40% load. And as you can see, the horsepower and torque values increase for each step. And so we did this 4 times, basically just to kind of get an average value and get good trend lines. And yeah, so I'm not real sure what these were meant to represent exactly. As you can see, they do increase with load, so it was kind of vague as to why that happens. So for some calculations, we did to the right are the constant values, and to the left are the measured values from our constant velocity run 1. First, we calculated air mass, which was found to be 0.0749 pounds per minute, and then volumetric efficiency of 94.67%, conversions efficiency of 78.14%, and mechanical efficiency of 14.44%. For breaking mean effective pressure, it was calculated to be 75.747 psi, and horsepower. So for this horsepower equation, all those numbers, values that I just said, you use them for this equation, and if the experiment was successful, your measured horsepower and your calculated horsepower should be relatively similar, and mine was pretty far off. And I looked back at some other experiments regarding this, and they kind of had the same thing. So I'm kind of thinking something might be up with the apparatus itself, as far as the measurement. But I got all the equations from the manual, and that's pretty much it. Do you have any questions?
So what do you think under which conditions the engine will be more efficient?
Under which?
Your conditions, like at what speed or load?
So engines are typically more efficient under slight load. I'm not sure why that is exactly. They like to run a little bit better. As far as running rich or anything like that, I think the richer you run, the less efficient your engine is because you're wasting fuel. But that's about all I really know about it. And the analysis for this experiment is pretty vague. I only had like 12 hours to look at it.
Yeah,
So,
yeah, you have to think, and then I think you will find those things.
yeah, that's about all I got. Any other questions?
Okay.